Hi everybody, it's Professor Barnes here. I want to take a look at section 8.4, which is the last new topic for chapter 8. And in this section, we're looking at hypothesis testing where we compare two population proportions. And if you remember, we did this at the end of chapter 7 where we created a confidence interval to look at the difference between the two population proportions. Now we're going to run a hypothesis test. So it's the same idea, and we're going to use StatCrunch to do our calculations and focus primarily on interpreting what it tells us. So let's start with a quick example. It says in April of 2021, Gallup polling reported that 13% of Americans felt that low income was their biggest financial concern. Then in June of 22, Gallup polling reported that only 10% of Americans felt low income was their biggest financial concern. Suppose that both of these came from surveys conducted on random samples of size 2,000. Can we conclude that the percentage of people who claimed low income was their biggest concern actually decreased from 2021 to 2022? So we're comparing populations from two different years. Those are going to be the two groups we want to compare. So it says, let P1 represent the proportion of Americans who felt that low income was their biggest financial concern in 2021. So P1 is what we want to estimate, right? That's the proportion for all Americans in 2021. And then P2 is the estimate we want to compare to the proportion of all Americans in 2022. So we are interested in comparing the relationship between these two population parameters. So when we do a hypothesis test where we compare two different groups, there's three possibilities, just like there would be where we're only working with one group. We're also going to have two hypotheses, just like always, a null hypothesis and an alternative hypothesis. So the first possibility is that we have a two-sided hypothesis test. The null hypothesis is that P1 equals P2. There is no difference between the two population proportions. But the alternative would be that the populations are different, so that would be P1 does not equal P2. So that would be the two-sided version of our hypothesis test, where the two proportions are different. A left-sided hypothesis test, so then in that case, the alternative would be the population for P1 is less than P2. So P1 is less than P2. And then the right-sided test, the alternative would be that the population for P1 is greater than P2. And those are going to be the three scenarios we'd be working with. So in the example I gave here, the question said, can we conclude that the percentage of people who felt this way was actually decreased in 2022? So if 2022 was P2, that means that we would be looking for P1 to be greater than P2. That would be our alternative in this example, because we want to know if there was a decrease, if P2 was lower than P1. You have to be very, very clear on who is P1 and who is P2. Make sure you define that at the outset. Don't let the word decrease confuse you. It's that P2 would have been less than P1, or P1 would have been greater than P2, whichever way you want to think about it. But this would indicate a decrease from 21 to 22, and that's what we're looking at. Now, in the notes here, I've got several versions of this formula, just like back when we did confidence intervals. I gave you the formulas, but we're not going to have to memorize these or even really use these. We're going to use StatCrunch to figure these out. But remember, P1 hat would be the number of successes for P1 divided by basically N1, the size of the sample for P1. And then P2 hat would be the number of successes for P2 divided by N2, the sample size for P2. So this test structure, the test statistic, would be the observed value minus the null value divided by the standard error. So the observed value would be the difference in P1 hat minus P2 hat. And then the null value would be 0, and then divided by the standard error. And it says the null value is 0 because our null hypothesis is that the difference between the two populations would be 0, because P1 would have to equal P2. That simplifies, of course, to this, and then the standard error would be computed using this formula. All right. Good news is you will not have to compute any of this by hand. We are going to use StatCrunch when we need to figure these out, or on the test, I will just give you the information you need and ask you to make the interpretation. Same conditions as what we had previously. The samples have to be random and independent, large enough to expect at least 10 successes and 10 failures from each sample. And then the samples, of course, have to be independent of each other. All right, let's go back to the first example. So the Gallup polling had 2 random samples. One was from 2021 and one was from 2022. Both samples, it said, had 2,000 people in them. So that would be your N1 and your N2. In the 2021 poll, 13%, which translates to 260 respondents out of that sample, said they felt low income was their biggest financial concern. In 2022, they said 10%, which would be 200 respondents, felt the same way. So I've gone ahead and summarized this in the table below. And in StatCrunch, this would be the information you'd have to put in. Remember, in StatCrunch, you can't put in percentages. You have to put in the actual number of successes from each sample. So this is how they would translate. And actually, I just noticed there is a little typo here. I must have updated these dates at some point. This should have been 2021, and this should have been 2022. So make that correction for those years in your notes. But the numbers are the same. So my hypothesis, the null hypothesis, would be that P1 equals P2. And then my alternative, remember, I'm looking to see if there was a decrease from 21 to 22. So that means that 21 would need to be greater than 22. Did it go down in 2022? Yes, the sample size are large enough, so I'm going to skip the conditions for now. We're going to go to StatCrunch, and the way we do this is exactly the same as we've been doing the other hypothesis tests. We go to Stat, Proportion Stats, but this time you're going to choose to sample with summary, and we're going to put the information in that I summarized for you in the table back here. So when you put that information in, and then you're going to adjust your hypotheses accordingly, it's going to give you this information here. This is the screenshot from what StatCrunch would have told us. So a couple of things to pay attention to. Our test statistic, remember, is the z-score, and that would be 2.97 right here. And then the p-value that corresponds with that z-score would be 0.0015. So our p-value is equal to 0.0015. If we want to go ahead and make a graph of this, 0, of course, would go right in the middle. 2.97, that is definitely an extreme test statistic that is outside of 2 standard errors of the mean. So that would put me right here, 2.97. Now, this is a two-sided, no, I'm sorry, I misspoke. I was going to say this was a two-sided test, but it's not. It's only a one-sided test. So that means I'm going to shade to the right. And so my p-value would be that shaded region in blue right there. So make a decision. They didn't give us a significance level, but remember we always default to 5%, alpha 0.05 rather. So our p-value is, in this case, smaller than 5%. 0.005, of course, is less than 0.05. So what does that mean? We will reject the null hypothesis. So we have evidence to support that the alternative basically is true. We think the alternative is true, that the proportion of all Americans who felt this way, whatever it was, about their financial concern, decreased from 2021 to 2022. So in other words, the economic confidence level, I guess, would have been a little bit better in that regard, going from 2021 to 2022. So in class, we'll do a couple where we use StatCrunch to get the data. Not a whole lot, though, because it does get a little bit tedious. But the main thing I want you to focus on is the interpretation. And that is exactly the same as what we did in the previous sections. We look at that p-value and compare it to the significance level and then make our conclusion on whether we reject or fail to reject the null hypothesis. All right, so that is it for 8.4. Bring your notes with you tomorrow, and I will see you in class.